The next type of problem we want to visit about is fixed supports. Now, fixed supports aren't any more difficult in general. In terms of the math, they are no more difficult than any other simple type of beam. However, students often have a hard time with this. And I think it's because of two reasons. First of all, they don't recognize a fixed support when they see one. And second is they forget how to draw the reaction. So I'm hoping that this class will be a little bit different. But first of all, let's recognize what a fixed support is. First of all, they resist both X and Y force, and they also resist a moment. So let's look at this simple one here. If I'm pushing down here, if this was a pin, it would clearly just rotate, unless there was something holding it up. But because there's nothing holding it up, and because it's not a dynamics problem, we know that something's going on at this fixed support that keeps it from just rotating this way. Therefore, this has to have some moment that it's resisting. So look for a fixed support as a, this doesn't make sense if it were a pin, I guess. So anyway, this is obviously a fixed support. It's a cantilever beam. Here's another one that looks like this. We've already talked about this one a little bit. This is not a cantilever beam. It's fixed to the base. But without something here that is something different from a pin, it would just move in this direction. This one here we've already solved a little bit, but this is a fixed support as well. If this was a pin, it would, well, which way would it rotate? By the line of action, the force would be going in this direction, and the lever arm would be this way. So it would rotate in this direction if that were a pin. But because it's not a pin, then there's something else going on here other than X and Y force. Same thing here. So anyway, what I want you to do is look carefully at what doesn't, or what makes sense as far as fixed supports, and then let's talk about how to draw the free body diagram and how to write the equations of equilibrium. So first of all, let's draw the free body diagram of this. So it's got an angle. Guess we can draw it like that. There's a force going this way, and it would tend to rotate. If this didn't, it would tend to rotate like that, unless something was, if this was a pin. But it's not a pin, therefore it doesn't rotate. And what does happen? It has got a X and Y reaction, AY and AX, and then it has the ability to resist moment. So there's going to be a moment about A, which is trying to keep it from rotating. All right, how about this one? In a similar kind of way, we've got a free body diagram. Got something going on out here. It's going to have some forces. It's going to have some lever arms. It will have something to keep it from moving this way. I don't know which direction AX is going to be, so I'll put AX like that. But my guess is it would tend to rotate. Let me put this like this. It would tend to rotate this way. Therefore, the reaction has to be in this direction. So I'll say moment about A as a reaction goes like that. So what I'm doing here is these are the reaction components. Let's go back up to here. These are the reaction components that you need to resolve. And we'll talk about how to resolve those in the next page. Okay, so here is a fairly straightforward beam. It's up at an angle. And what we want to do is find the reaction at O. It's probably easy by now that we've talked about it, that this would be a fixed support. It's not a pin. It's going to tend to rotate in this direction. Therefore, the reaction has to be in this direction. That keeps it from rotating. So let's go ahead and draw the free body diagram, and then we can solve for things. This is kind of built up a little bit with that little thing there. So what I'm going to do is I'm going to draw the components of the force. It's going to have components going in this direction and in this direction. Because this is angle 30 here, this is angle 30, so I'm going to call this 600 cos 50. And then this will be 600 sine of 50. here's my point of concern. So let's draw our reaction. I'll say that there's an OY and an OX. Because this is a cantilever, a fixed support, I know there is a moment about O that looks like that. All right, let's see if we can find out the moment about O. Sum of the moments about O is equal to 0. Counterclockwise positive. What have I got? Well, I have this component, this cosine 50, times this lever arm. So if I look right here, it looks like it is 0.5. And this sine component has this lever arm is 5. So let's go ahead and put those in there. That'd be 600 cos 50 times 0.5 plus 600 sine 50 times 5. And now I can find the reaction moment. I beg your pardon, I left something out here. That is going in the positive direction. And then the reaction is going in the negative direction. This is what this reaction is all about. In order for this to equal 0, I have to put that reaction in there. So that would be minus the moment about O is equal to 0. So that reaction, just like a force reaction, has to be in the moment equation. Now I can sum that up and find out what the moment about O is. And I got the moment about O. Reaction is equal to 2941 pound-feet. Okay, how about the forces in the X and the Y? Well, those are slightly different. However, let's go back up to the original picture and see what we can see. What I have here is two components in X and Y. In other words, I have 6 cosine 20 going that way and 600 sine 20 going in that way. Alright, so let's sum the forces in the X and the Y then. Let me go back down here. And let me zoom out here. That way we can see it all. Alright. So sum of the forces in the X is equal to 0. So I have OX in the positive direction minus 600 cos 20 equals 0. And so OX is equal to 564. And then sum of the forces in the Y is equal to 0. So I have OY positive plus 600 sine 20 equals 0. So OY is equal to negative 205. And that is it, both in pounds. Note the directions of the arrows and the directions of the answers, or the sign, S-I-G-N, of the answers, and that'll keep us on track. Okay, so here's one I would like you guys to do. It's not very hard, but just to give you some practice. Draw the free body diagram and find the reaction. And I'll give you a minute or two to do that. Okay, so here's the solution. Again, recognizing that this is a fixed support, I have a force going up, 2 components of that force and 2 components of this force. So I've drawn those on the free body diagram. The reaction over here is especially important. I have an AX and AY, and I'm guessing that the moment reaction is going in this direction. I think that's probably true, but we'll see as we solve it. So some of the moments about A, let's see what A is. I got 200 times 3 going that way, 80 times 6 going that way, 50 cosine 30 going this way, times all have different lever arms. And then I add the moment reaction going there, and I get moment of the moment of reaction about A is negative 509. So I did draw my arrow incorrectly. So the reaction is actually going the other way, but that's okay. I drew it as a positive, I solved for it as a negative, and that agrees with, that's the correct answer the way we do it. Some of the forces in the X direction, I got minus AX, I got these two going in that direction, so we got AX is positive 85. And then some of the forces in the Y, Again, I got AY is positive, that's negative, that's positive, and I got AY is equal to a negative 163. So what you'll find is sometimes it's easy to get the forces and the moments in the correct orientation to start with, and sometimes it's not, but it's perfectly reasonable and appropriate to leave them as negatives as you solve your problem.